Hi everyone and welcome to another episode of STEM in Seconds. Today we're going to be talking about factorising. Now first off, what is factorising? Factorising is the process of removing a common factor from an expression to make it a little easier and simpler to work with. So the most basic form of factorising is removing a common factor. For example, in an expression like 3x plus 9, we can rewrite this as 3 times x plus 3 times 3. This gives us a common factor of 3 in both of the terms of this expression. What this means is that I can rewrite this expression as 3 lots of x plus 3. So I take the 3 out of this term and the 3 out of this term, and this is what's left, an x plus 3. This can be done for slightly more complicated expressions as well. So for the expression 4x squared plus 8xy, this may look a bit complicated, but if I rewrite this, I'm going to have to do it below, as 4x times x plus 4x times 2 times y. You can see 4 times x gets me 4x squared, and 4x times 2 times y gets me 8xy. I've now created a common factor of 4x in both of these terms. Pulling that 4x out allows me to write that expression as 4x lots of x plus 2y, which is much nicer than that. Now we've mastered what factorising is, we're going to look at the most common type of factorising, which is where you have to factorise a quadratic. These will be in the form of ax squared plus bx plus c, usually equals 0, but we don't need to worry about that for now. The rule for a quadratic is that it will always factorise into 2 brackets. We're going to demonstrate this with my first quadratic, which is x squared minus 5x minus 6. In this case, a is 1, b is minus 5, and c is 6. Now keep that in mind, we're going to need it later. For a quadratic, first thing you do is identify your b and your c. In this case, as I said, b is minus 5 and c is minus 6. In this case, a equals 1. So the 2 brackets you're going to end up with will be x plus something and x plus something else. The coefficient of each x is 1, because that's the only way to get this 1x squared here, which means you are looking for 2 numbers. Now these 2 numbers will add to get minus 5 and multiply to minus 6. The easiest thing to do is to start with the multiplication angle. To multiply to get minus 6, you need minus 6 times 1, minus 1 times 6, minus 3 times 2, or minus 2 times 3. Those are the only combinations of numbers that will multiply to give you minus 6. The next thing to do is add them together. In this case, minus 6 plus 1 is minus 5, so I know that's the right one. But just to double check, minus 1 plus 6 is 5, minus 3 plus 2 is minus 1, and minus 2 plus 3 is 1. As you can see, there is only one row in this table where that matches in both cases. That means I know that my 2 numbers inside the brackets will be 6 and 1. So this quadratic factorises to x minus 6 and x plus 1. And if you expand this bracket to check, you will get this equation. The next quadratic we're going to look at is one where this a doesn't equal 0. So we're going to look at the quadratic 2x squared plus 5x minus 3. As you can see, this a is not 0, so my a is 2, my b is 5, and my c is minus 3. The first thing to look at when this a is not 1 is what are the possible multiples of x in the brackets. It's a quadratic. You know it will factorise into 2 brackets, each with 2 terms. One of them an x term and one of them a not x term. As this 2 is a prime number, there is only one possible combination, and that is an x multiplied by a 2x, which means those are the x terms in the brackets. just fill those in. Now, inside these brackets is another number, so I'm going to call it E and F. If I then expand these brackets on this little side note over here, I get 2x squared, 2x times f from my outside, plus ex from my inside, plus ef for my lasts. Now there's a 2x that matches here, so that means I now know that e times f equals minus 3 from my c component, and e from here plus 2 multiples of f will equal my 5. Again, first thing to do here is you start with the multiplication. So e times f equals minus 3. My only options here are minus 3 times 1 or minus 1 times 3. The next thing to do is to try and get 5 in some possible combination. So we can do minus 3 plus 2 times 1, or 1 plus 2 times minus 3. Again, we can do this in the bottom, minus 1 plus 2 times 3, or 3 plus 2 times minus 1. As you can see, I've pulled the e plus 2f into each of these possible sets of numbers. Now, the thing I have to find out is which of these 4 equals 5. In this case, it's this one, minus 1 plus 6, 5. Feel free to work out each of these to check, but I'm not going to today. This tells me that my e must be minus 1 and my f must be 3, which means the final expression for this quadratic is 2x minus 1 multiplied by x plus 3. The final thing I'm going to show you today is a little trick that we call dots. And this stands for the difference of 2 squares. What that means is x squared minus y squared. I have 2 squares and it's a minus, which means I'm looking at the difference between them. Now this x squared and y squared could be anything, and the one I'm going to show you is x squared minus 25. This 25 can also be expressed as 5 squared, and this can be factorised into x plus 5 multiplied by x minus 5. And that's a trick it's very useful to know. Examiners will very often use a difference of 2 squares in their questions to try and catch you out. The reason that this goes to this is if you expand this expression, you get x squared plus 5x minus 5x minus 25, which simplifies to x squared minus 25. So this works in both ways. Whenever you see something squared minus something squared, you can easily factorise it into these 2 brackets, using the square root of both of the original terms. That's all for this video. Please don't forget to comment down below if you have any ideas for new videos, and don't forget to subscribe.